solve inequalities? I want you to notice something. When we learn to solve equations, when we solve equations, we looked at some properties of equality. Now, properties of inequalities that I want you to be aware of. Suppose that I start with an inequality that you know is true. For example, do you buy that? Consider this. Do you buy that inequality? 8 is less than 12. True or false?
True.
True. Now suppose that you start with an inequality like this one, which is true. What would happen to this inequality if I add the same number to both sides? Suppose that I add 2 to both sides of the inequality. Let's see, 8 plus 2? 10. 12 plus 2? 14. How does 10 compare to 14? 10 is less. So notice that in this example, by adding the same number to an inequality, the inequality stays the same. So it seems that, and that should make sense to you, right? If we come into a job, for instance, with a certain amount of money in our wallets, I have less money than Dora, and then we both get paid $80. $80. So I get $80, and she gets $80. Who's going to have more at the end of the day? Dora still has more because she came in with more, and we got the same amount extra, so the inequality still holds, right? So adding a number to an inequality doesn't change the inequality. Let's keep going. So 8, 12. Suppose that I subtract a number. I don't know. Let's take a number like 10. Let's subtract 10 from both sides of this inequality. What's 8 minus 10? What is 12 minus 10? How does negative 2 compare to 2? Negative 2 is less than. Did you change the inequality? No. If you have an inequality and you subtract the same number from both sides of the inequality, your inequality is going to remain the same. All right, so it seems as though an inequality behaves a lot like an equation. Let's keep going for a second here. 8 is less than 12. What happens if I multiply by a number like 5? Let's see, 8 times 5? 40. 12 times 5?
60.
How does 40 compare to 60? Not a problem. Look, the inequality remains the same. Multiplying by a number like 5 doesn't do anything to the inequality. Now let's see what happens when you divide an inequality by something. Let's divide here by 4. A divided by 4? 12 divided by 4? 3. And you can see that the inequality still holds. 2 is less than 3. So here's what I wanted to point out to you. When you have an inequality, you can add a positive number to both sides. You can add a negative number to both sides, or subtract, the same thing. You can multiply by a positive number. You can divide by a positive number. And in all these cases, the inequality stays the same. The only warning, or the only time you have to be concerned about your inequality sign, is when you multiply or divide by a negative number. Let's check what happens then. 8 is less than 12. Let's divide or multiply. Let's multiply by negative 5 and negative 5. What is 8 times negative 5? Negative 40. What is 12 times negative 5? Now, think about this for a second. How does negative 40 compare to negative 60? So if you think of the number line, right? Here's 0. the number that's more to the left is less. Which number would you come to first? 40. The negative 40 would be somewhere here, negative 60 would be somewhere over here. So which one, how does negative 40 compare to the 60 now? Is greater. So when you take an inequality and you multiply by a negative number, the inequality reverses. Right? In other words, yeah, you have a number here that has a greater absolute value, but is now further away to the left. That's why now this number is worth less than this one. This is the only warning, and the same thing happens when you divide. If you can understand this step, that solving an inequality is exactly the same process that we go through when we solve an equation, except when you multiply by a negative or you divide by a negative. Let's divide here so you can see it. Let's divide by negative 4. Both sides of these inequalities here. What's a divided by negative 2? By negative 4. A divided by negative 4 is negative 2. 12 divided by negative 4. How does negative 2 compare to negative 3? It's greater. Negative 2 is worth more than negative 3, right? Because this is more to the left on the number line. So here's the only thing that we're going to conclude here. When we solve an inequality, we use the same steps that we use when we solve an equation. But we reverse the inequality sign whenever we multiply or divide the inequality by a negative number. Okay? So, we're just going to do a couple of examples here. And then I just want you to solve each inequality and graph its solution on a number line. All right, try that. If you can do equations, then you can do inequalities. So you think of that inequality sign just as an equal sign. All right. Just keep writing it. This will cancel out, right? Correct. 2x. Do I have to worry about my inequality? No. No, it stays the same. Divide by 2. Do I need to reverse this? No. 5. This is your solution. All the numbers that are greater than or equal to 5. And when you graph the solution on a number line, you're going to say 0. You go to 5. You put a closed circle. And then you say to the right. To the right. Questions?
No, this is
all right. Pretty straightforward. Second problem. So you should have gotten rid of the parentheses first. (2x minus 10 minus 2 is greater than 4x plus 7. If you do this the way that I showed you to do equations before you attempt to cancel from either side, you combine like terms right here. Simplify this. So you get 2x
Yes.
minus 12 is greater than 4x plus 7. Now when you're doing equations, I told you it didn't matter whether you subtracted the 2x or the 4x, it makes no difference. Here, I'm going to tell you that things will be easier for you. Things will be easier for you if you subtract 4x from both sides to keep the variables on the left. So we're going to subtract 4x. So what's left here? Negative 2x minus 12. Do I need to reverse the sign since I subtracted? No. Only when I multiply or divide by a negative number. So the 4x cancels. I have 7. Add 12 to both sides, just like an equation. You would add 12. And I get negative 2x is greater than 19. Now here comes the key step. I'm about to divide. To solve for x, I need to divide by negative 2. The moment I do that, this inequality is no longer true. So I cross this out to remind myself this is gone now. I have to reverse the sign. When I divide by negative 2, the original inequality doesn't hold anymore. So I get x is less than negative 19 halves. Now when you're graphing something like that, this is your answer.
That's the same as 9 and a half, negative 9 and a half.
Right, you could now, in order to know where to put that number, right, you would probably change it into a decimal, 9.5 or 9 1/2.
Wait, why did you change the sign? Because you divided by a negative.
Whenever you divide an inequality by a negative sign, the sign gets reversed. So here's 0. 19 halves, negative 19 halves is
Divide that to a decimal.
negative 9.5. You can change it into a decimal. I'm going to leave it as a fraction here and say that's negative 19 halves. Is it an open circle or a closed circle? Open, we want to exclude. And we're going to shade to the left. Less than, right? X is less than. All right, so when you go home this weekend, make sure that you work on activities 3.14 and 15 now. You have everything from this week was 3.12 through 3.15. Have a wonderful weekend and safe trick-or-treating.